Let us see electrochemistry numericals. In electrochemistry numericals, what are the points we will see? We will discuss. In electrochemistry numericals, what are the points we will discuss? What are the points we have to see? We will discuss. In electrochemistry numericals, let us take first numerical. Electrochemistry numericals we will take. In that, let us see this first numerical. Let us see this first problem. You see, first problem. You see the first problem. This first problem we are seeing. This first problem, you see that first problem. Let us read. A test for a complete removal of Cu2 plus ions from solution of Cu2 plus aqueous is to add ammonia aqueous. A blue color signifies the formation of complex CuNH3 4 times 2 plus having Kf is equal to 1.1 into 10 power 13 and thus confirms the presence of Cu2 plus ions in the solution. Let us see what is the meaning of this. Let us see what is the meaning of this. Let us see what is the meaning of this. Let us see. Okay. Now, let us take a group separation of cations. In the group separation of cations, let us see second group. In the group separation of cations, let us see second group. In the second group, what cation is there means Cu2 plus aqueous. For the second group, what is a reagent in the sense H2S gas is the reagent. H2S gas is the reagent. Okay. Now let us take a second group cation, that is Cu2 plus. Let us take copper sulfate salt. Copper sulfate salt we will take, it is solid, its color is light blue. Copper sulfate salt color is light blue. Sorry. Copper sulfate salt we have taken. To this let us add water. We will get a copper sulfate solution. Copper sulfate solution. In the copper sulfate solution, what are the ions will be there means Cu2 plus aqueous and SO4 2 minus aqueous. SO4 2 minus aqueous. This solution, how it will be appearing in the sense almost colorless. Almost colorless. You may be asking that copper sulfate is having blue color. No, then how do you say that it is almost colorless? Of course, copper sulfate is blue color. There is no doubt it is light blue. To this you are adding water, you are getting copper sulfate solution. It is dissolving. Copper sulfate is dissolving in water, so you are getting copper sulfate aqueous. In the copper sulfate aqueous solution, what are the ions present means Cu2 plus aqueous and sulfate aqueous. It is almost colorless. Like this only it will be there. If you see practically, if you see, it will appear like this only. Sorry, okay. Now let us take ammonia solution. This ammonia solution is colorless. Ammonia solution is colorless. Let us add ammonia solution into this copper sulfate. What will happen in the sense, you will get a light blue precipitate. You will get a blue precipitate. The blue precipitate is what in the sense CuOH twice. CuOH twice precipitate you will get. Okay, Cu2 plus from here we are saying, okay, that Cu2 plus. We are adding ammonia only. No, how we got OH minus? That means ammonia aqueous is nothing but ammonium hydroxide solution. Ammonium hydroxide solution. Ammonium hydroxide solution formula is what in the sense NH4OH. Therefore, we are getting a hydroxide. Therefore, we are getting hydroxide. Ammonia aqueous means ammonium hydroxide solution. Ammonium hydroxide solution is having OH minus. Therefore, Cu2 plus takes this OH minus and becomes CuOH twice precipitate. You will get blue precipitate. Sir. Then we are adding still more ammonia. We are adding still more ammonia. What happens means precipitate dissolves. Precipitate dissolves. Why precipitate dissolves in the sense due to formation of complex. What is the complex formed here in the sense the formed complex is CuNH3 4 times 2 plus. It is the complex formed. It is the complex possible. Sir, what complex possible that we said. Okay. In the group, this complex color is what means blue. That means deep blue. Blue color is visible. Now intensity of blue color, intensity of this blue color, intensity of this blue color, if you see, The intensity of blue color is higher, intensity of blue color is lower. Sir. Next we will say what is called a formation constant. What is called a formation constant? That point we'll see. What is called a formation constant? Kf is called what? Kf is called formation constant. Kf is called what means formation constant. Now we will see Kf of CuNH3 4 times 2 plus CuNH3 4 times 2 plus Kf of CuNH3 4 times 2 plus we will see. How to write equation for this, that we will see. Here see the Kf is called what? In this Kf, F is called what? Formation. Formation of what? This complex. Therefore, in the equation right side you write the complex. Why we have to write a complex as a product? Because here F is called formation. Formation of what? Formation of complex. Therefore, complex is the product. Sir, okay. We got a complex as a product. What is a reactant? What is a reactant? We have to see. So what is a reactant in the sense, now you see how this complex is formed. You see how this complex is formed. The complex is formed by taking copper sulfate and water and ammonia. So this copper sulfate, this complex is formed from where? Cu2 plus aqueous. This complex is formed from Cu2 plus aqueous. Therefore, Cu2 plus aqueous is a reactant. Cu2 plus aqueous is a reactant. So we are writing here Cu2 plus aqueous. Cu2 plus aqueous we are writing. Next, Cu2 plus aqueous we have written. Next, you see that this complex is possible by adding ammonia. By adding ammonia, this complex is formed by adding ammonia. This complex is possible due to addition of ammonia into Cu2 plus. So Cu2 plus combining with ammonia to give this complex. Therefore, we have to write here we have to write what means ammonia. We have to write ammonia. We are writing ammonia we are writing. That means this Cu2 plus combining with ammonia to give the complex. Now let us balance this. For balancing we are keeping like this. Now let us consider this as equilibrium. This as equilibrium let us consider. Under equilibrium condition, this equilibrium is having equilibrium constant. That equilibrium constant is called Kf. So for this equilibrium constant is called what means Kf. So Kf of complex, formation constant of this complex in the sense we have to write equation like this. So let us take one more example for Kf. Suppose we are taking a Kf of AgNH3 twice plus AgNH3 twice plus. How do we write equation for this? Let us see. Now let us write equilibrium symbol. Now F is called formation. Formation of what in the sense complex. Therefore complex we have to write in the right side. We are writing complex in the right side. Okay. Left side what we have to write? We have to see. For that case, this complex is possible from where you have to see. This complex is possible from where in the sense for this we will see the test we will see. Suppose we are doing a chloride confirmatory test. Chloride confirmatory test means we will take chloride aqueous we will take. For example, copper cupric chloride salt, CuCl2 salt. Chloride salt we will take aluminum chloride salt. If you dissolve aluminum chloride salt in water, you will get Cl minus aqueous. Now, for this confirmatory test is what means adding silver nitrate solution. What we will get in the sense AgCl precipitate. AgCl precipitate. To this AgCl precipitate, to this white precipitate, let us add ammonia. If you add excess ammonia, the precipitate dissolves due to formation of complex. Due to formation of complex. Complex is possible like this. Complex is possible like this. Now see that in the salt analysis, chloride analysis we are seeing, chloride salt we will take, we will dissolve chloride salt in water. That salt is having Cl minus aqueous. To that you are adding silver nitrate aqueous. You are getting white precipitate, silver chloride precipitate. To this if you add excess ammonia, precipitate dissolves due to formation of complex. Now say the complex is possible from where? You see, this complex is possible from Ag plus of AgCl, no? Ag plus of AgCl, no? Therefore, here you have to write Ag plus aqueous. Then this complex is possible. This complex is possible from ammonia, addition of ammonia. Therefore, you have to write NH3 aqueous. For balancing this, you will write 2. For balancing this, you are writing 2. So that for this Kf of complex, formation of this complex, how to write equation means formation of this complex you have to write. In this complex, silver is having +1 oxidation number, that you have to write as Ag plus aqueous. Then you are writing this ammonia. Ammonia you are writing like this. Ammonia you are writing like this. Okay. So now we got an idea what is Kf, what is formation constant. That idea we got. Sorry, okay. Next, we will continue the sum. We will continue the sum. We will continue. In the sum, first line you see that first sentence you are seeing a test for complete removal of Cu2 plus ions from the solution of Cu2 plus aqueous is to add ammonia aqueous. A blue color signifies the formation of complex, that is complex is given having formation constant. See the formation constant how much given? 1.1 into 10 power 13. 1.1 into 10 power 13, and thus confirms the presence of Cu2 plus ion in the solution. Now let us see this formation constant value. This for this complex, what is the Kf value given in the sense 1.1 into 10 power 13 given. Now let us see that value. Let us see that value. Now for this complex, Kf value is given. Kf is how much means 1.1 into 10 to the power of 13 given. Kf is this much. Equilibrium constant is this much. You see that equilibrium constant is this much given in the sense equilibrium constant, this Kf is equal to, what is the formula in the sense numerator. In the numerator you have to write right side, you have to write in the numerator. Then left side you have to write in the denominator. Left side you have to write in the denominator. Left side you are writing in the denominator. Okay. You see that Kf is 10 power 13 in the sense this numerator will be very high when compared to denominator. You see that Kf is equal to 10 power 13 in the sense numerator is much high when compared to denominator. This indicates equilibrium lies